Hey everybody, thanks for checking into another math video. This one is going to be about completing the square. And you may have never seen anything called completing the square before. This might be your very first introduction to the process called completing the square. So let me introduce it properly by saying that this process, completing the square, well, it's an algebraic process that converts a standard form equation into a vertex form equation. All right? And now, I'm hoping that you've seen the video that I posted called Solving Vertex Form Equations, because that part of the process I'm not really going to talk about too much in this video. This is about completing the square, which just changes one form into another. All right? So in other words, it starts off with an equation like this: x squared plus bx plus c equals 0, and we're going to change it into an equation that looks more like this: x minus h squared equals k. That's the vertex form there on the right. Okay, so that's what the process called completing the square actually does. Now, you may have noticed something about that standard form equation that I just wrote there. It's missing the a value, all right? And that is not by accident. The reason is because this process called completing the square really only works when a is a positive 1. Okay? In other words, it's 1 times x squared in the equation, which means you really don't have to worry about a. You're not going to use it if a equals some other number, so just don't even worry about a here. Okay? All right, so, let me just say this. You would want to use this process actually to solve a quadratic equation that usually cannot be factored. All right, now I'm saying that here because this is what most people do. All right, when they come across a standard form equation where a equals 1 and it cannot be factored, this is, for a lot of people, this is kind of their go-to process to solve that equation. You could use it if it is factorable. It doesn't have to be unfactorable before you can use this. It's perfectly fine to use it if it's factorable. All right, so if you don't like to factor, you could use this. As long as a equals 1, that's really about the only thing that has to be there. Okay. All right, so we are going to take a look at the steps of this process, and there's really only 3 steps. And we're going to use an example. Okay, that example that I write will be in this form: x squared plus bx plus c equals 0. I am going to use those b and c terms a lot, so I'm going to put that up there for your quick reference there. Here's the equation we're going to solve: x squared minus 10x plus 6 equals 0. All right, so there's the equation we're going to solve. You notice that a does equal 1, and this cannot be factored. Okay, so step 1. What we're going to do for step 1 is move the constant term to the other side of the equal sign. Okay? Now the constant is the c term. I think it's just a coincidence that constant starts with c, but what the heck, we'll take it. It's the constant because it doesn't have an x value on it. It's just a number. It's a constant number, and we're going to move that to the other side of the equal sign. Okay, so it looks like this then: x squared minus 10x equals negative 6. All right, you saw the positive 6 on the left becomes negative 6 on the right. Don't make sure that you do that little sign change there. It's very important. Notice that I've left a little space there, okay? That's because in step 2 of the process, we're going to add a number right there. In fact, we're going to add that same number to both sides of the equation. And you know, don't you, that if you add the same number to both sides of an equation, everything's good. You haven't really changed the equation. It's still true. And the number that we're going to add is very special. We're going to take the b term and take b over 2 squared, and we're going to add that to both sides of the equation. All right, so in this case here, b equals negative 10, right? b equals negative 10. So think in your minds there, negative 10 over 2 squared. All right, negative 10 over 2 is negative 5. Negative 5 squared is positive 25. So what we're going to add is 25 to both sides of the equation. Okay? That's the middle step, and is one of the most important steps of the whole process. And it's not really that hard. Okay? So there we go. You see x squared minus 10x plus 25 equals, and then that 25 minus 6, we'll simplify that down to 19. All right? But now our third step is to factor the left side, factor the x squared minus 10x plus 25 into a perfect square binomial. All right? That's some pretty fancy math terminology there, perfect square binomial. But you've seen a lot of them, okay? It's just a binomial, so it's like x plus a number or x minus a number in parentheses That's the binomial, and it'll be squared. Okay, so it's going to look like this in this case. X minus 5 squared equals 19. If you don't like factoring, you might think that this process is harder right here, but I'm going to show you a trick on factoring this, and I would like you to notice that x minus 5 there, that number, that minus 5, it's 1/2 of the original b in the equation. We had negative 10 equals b right above it, so we're going to just take half of that, and that's the number that goes in there. Okay, so you got x minus 5 squared equals 19. It's ready to solve. And we're going to solve it now by taking the square root of both sides, but I do want to make clear that by now we have completed the square. The square has been completed. All right? What we did is we took that number, b over 2 squared, we added it to both sides, and that is the only number in the universe that will allow that left side to be factored as a perfect square binomial. So that's why we say the square has been completed. We added the right number so that we could complete the perfect square there. All right. Remember, we said that wasn't factorable before, but now it is factorable as a perfect square binomial. All right. So now you're going to solve by taking the square root of both sides, and I'm going to kind of go quickly through this part because I'm assuming that you've already seen that video about solving vertex form equations. And so then we get our solution. Don't forget the plus minus sign, right? And you get 5 plus or minus the square root of 19. That's our solution to that equation. All right? You can write it as one expression like that, or you could break it up into two. It doesn't matter to me. Okay? Whatever you like. Let's try another one here. Okay? Oh yeah, French. Voila. There we go. All right, let's try another one. X squared plus 8x minus 5 equals 0. We're going to move the constant over to the other side of the equation, and then we're going to look at b. All right, so there's the first step. Now look at b. b over 2 squared, that will be 8 over 2 squared. 8 over 2 is 4, and 4 squared is 16. So we're going to add 16 to both sides of the equation. All right, cool. X squared plus 8x plus 16. And then the right side is going to equal 21, okay, because 5 plus 16. But now we factor that left side, all right, it's going to be x plus 4 squared is the perfect square binomial. And I know you may be thinking that this is a coincidence, or maybe you're not, but anyway, it's not a coincidence. That number that you're looking for there, that is always going to be half of b. All right, so this factoring part of this process, this 1, 2, 3 step process, it's easy. You don't really have to worry about factoring, okay? You always just take half of b, and that's the number that you're looking for there. And now we're going to solve by taking the square root of both sides, and you get 4. Actually, you get x equals negative 4 plus or minus the square root of 21, which as I said, you can write it as one expression like that with the plus minus in it, or you can break it up into two numbers like that, negative 4 plus root 21 and negative 4 minus root 21. You can say them either way. Again, that's up to you. Let's do one more. This one will be a little bit different because of b. Yes, we are going to move that constant over to the other side, but I do want you to think about b for a second. b equals 5. 5 is an odd number. And when you take b over 2, that means 5 over 2. 5 over 2 squared. Well, 5 over 2 is not a whole number. So you may have to use a calculator here. That's okay. Go ahead, use a calculator. 5 over 2, that's 2.5. 2.5 squared equals 6.25. Okay, that's what we're going to add. We're going to add 6.25. That's our b over 2 squared number. All right, but first we're going to move the constant over to the other side, and then we add our plus 6.25. That gives us 26.25 on the right side. So that's step 1 and step 2 of the process. Step 3 is to factor that. Okay, and notice once again, it's 5 over 2. It's b over 2. That's what the number is that goes in the parentheses here every single time. No exceptions. You could write it as 5 over 2, or you could change it to 2.5. I don't really care. That's up to you. And then one more time, you take the square root of both sides and you solve it, and you're done. You've got your solution to that equation right there. Okay, step 1, step 2, step 3, and solve. Okay. It's pretty easy. It's, in fact, I don't know if you've ever made pancakes, but by looking at the box, you know, the box of pancakes there in your kitchen, and you look on the side, you got to add an egg and then do some milk, maybe some oil, maybe some water. Mix it up and put it in the bowl, put it in the pan, fry them up, and get your pancakes, and the pancakes are nice and tasty. But this is easier than making pancakes, okay? If you can follow a recipe about making pancakes, you can complete the square. It's easier. It takes less time. Okay, it's not as tasty, but it's very easy to do, okay? So time for a quick summary here. Quick summary on completing the square process, all right? First thing is just what it is. Completing the square is used to change standard form into perfect square form. Actually, let's call that vertex form, and that's for easy solving, okay? Change the standard form into vertex form because it's easy to solve, okay? Like x squared plus bx plus c becomes x minus h squared equals k, all right? That's your standard form into vertex form. Now, don't forget about the b over 2 squared. That is the magic number that allows you to complete the square and to write it as a perfect square binomial. All right? And then finally, what you're going to do is solve the equation by taking the square root of both sides. Don't forget the plus minus. All right? And because that's how you get both of your solutions. Okay? All right, very good. I'm glad you watched. Watch it again. Look at more examples if you like. Enjoy what you're doing, please. And by all means, trust the process. Okay? All right, take care. Thanks for watching. I hope you're doing well. Bye-bye.